Hey there, this is Seth Warris from Channel 9. We're here at the PyData conference here in, well, it's PyData Seattle, but we're actually in Redmond in Building 33, and I have a special guest. It's lunchtime, so I thought I'd talk to some of the people that are actually here and talk a little bit about Python and what's going on in the community. So why don't you introduce yourself, my friend?
Sure. So my name is Sharok Mortazavi. These days I run the data science tools at Microsoft.
Okay.
That team owns Python, it owns R, the Python Azure SDK, which gives you Pythonic wrappers for all the Azure services, and also Jupyter Notebooks as a service. So if you go to notebooks.azure.com, you get a beautiful environment for R, Python, F#, with all the relevant distros behind it, and you can instantly start computing.
So let's start with this notion of, because there's an entire group devoted to data tools. Why is data so important? That's the first question. And then we'll get into some of these languages that are supported. Why are these languages very apt for dealing with data? Let's start with why is data important nowadays?
Sure. So basically, in the last 10, 15 years, especially as some inflection points have happened from IoT, from gathering data, click data, whatever telemetry you might think, people have been piling up this data, and at some point people said, look, there is some needles in this haystack. How do we go around about finding them? And lots of various technologies, from classic databases all the way to the most leading edge deep learning frameworks, have tried to tackle this from different angles, building layers of software that ultimately try to gather intelligence out of this data that is somehow actionable, whether it's a driving car that needs to do automatic braking or lane detection, all the way to guessing, we were talking about translation earlier. So the domain is wide and deep, and what affects change in this environment is some of the tooling and frameworks that have come about that have enabled developers to basically build solutions that answer some of the questions.
So let's talk about the languages, because you mentioned a number of different languages that Microsoft supports, because you work on Microsoft tooling for these. Let's talk about some of those languages. Specifically, we'll talk about Python a little bit later, but what are those languages that we support?
So at Microsoft, the key languages at the top are obviously anything .NET focused, like C#, and the family like F# and VB and so on, and C++ as the system software, OS software, and of course the JavaScripts of the world, that whole family and its derivations. But when it comes to data, there are languages like R and Python and up-and-comers like Julia that have focused on that zip code. And I would say it's not so much because of the languages themselves. The languages are fine, they're easier, they're more approachable. Most of them are dynamic languages, but it's really the ecosystem of the packages and the libraries that are available. Like, go to PyP, which is the Python package index, and type anything, like from astronomy to biology to data science to just type Excel. You will see there's like 3,000 packages on how to automate Excel, how to deal with CSV files, and so on. So deep and wide in terms of application of the packages that are available.
And so it's not necessarily the languages, but it's the community around these languages that have sprouted up that really make it powerful.
It's a combination of both, but I would personally say that the ecosystem and richness of the libraries has a lot to do with it. I would say it's 70% the libraries, 30% the language. Like if .NET had such a rich library of machine learning stuff, it would probably be more in use in that domain. Which really means is like, for the newer family of deep learning libraries that are all written in C++, we should have .NET bindings for them, so all the .NET developers can also use them.
And I know CNTK, for example, already has Python bindings for the training side, but it also has C# bindings for the prediction side, as far as I know, which is kind of cool.
Yeah, I mean, consumption of this stuff. The idea here is like you don't have to have a PhD in data science to actually use this stuff. Somebody builds a package, it's like a library call, here's my information and what do I call for a prediction. That should be available to anybody. Yeah.
So you talked about the frameworks and the ecosystem are what makes some of these languages or these communities very robust. Let's talk a little bit about the tooling, specifically from the perspective of Microsoft, because we have a number of different developer tools. Why don't you discuss a little bit about what we're doing to enable these communities to plug into our ecosystem?
Sure. So we have a number of technologies going all the way from Azure side of things to databases like SQL that now have R and Python built in, all the way to SDKs that provide all the, from compute to storage to management services, all the way to developer tools like IDEs like Python in Visual Studio, R in Visual Studio, Jupyter Notebooks, all the way to the deep learning frameworks like CNTK. So we have a wide range of technologies that pretty much address the whole spectrum of needs of a Microsoft developer.
So if someone's a Python developer out there, and let's just say they want to use Visual Studio Code, why don't you talk a little bit about like what the ecosystem is like, what tools can they use to make their development a little bit better, or maybe Visual Studio, any of the tools, because I love the way you talk about it in general, but let's see if we can dive into specific use cases that people have been doing.
Right. So VS Code, for people that don't know, is a lighter weight IDE or editor plus that we provide, multilingual, very quick and very fast. Doesn't have the complexities of Visual Studio. So there's a beautiful plugin written by Don Jayamani that essentially provides the syntax highlighting, debugging, everything that you need for Python development. And it's literally a matter of installing Anaconda, the Python distro that has 200 to 300 packages, and pip installing whatever else you want to have a rich, ready-to-go Python development environment cross-platform on your machines. If you're on Visual Studio, when you install Visual Studio 2017, there's actually a checkbox that says for a workload called data science. Okay, the data science workload gets you R, gets you Python, gets you F#, and gets you Anaconda and the R distro, the Microsoft R runtime, the enhanced Microsoft R runtime. And all of those with a single click, and you're absolutely ready to go. And then on the cloud, we have Azure ML Studio. This is a web-based environment for building your experiments that instead of just being directly in typing code, it's actually a graph that you can have. It's a DAG that you can basically have your inputs, outputs, processing nodes, and so on. And you can basically do your training. At any point, you can right-click and say, let me look at this in a Jupyter Notebook. Eventually, you end up with an endpoint that you can press a button, it zaps it to Azure, and then you can start calling it to do your predictions or whatever it might be. So we've got a rich set of tooling available for developers to build their models.
So let's talk about Python in general, because I've always wondered, my Python experience probably ended in earnest once I was done doing research, probably around 2009, 2008.
Okay.
And I had Python 2.7 installed. You mentioned Anaconda and a number of other different things. What is it like? What is Python like today that I'm missing, that I've sort of missed out on?
Right. So Python, there's a 2x world and there's the 3x world, right? So basically, there were a number of, let's say, column decisions that were made earlier that had to be addressed sooner or later.
Sure.
And there was basically a flag day, a breaking change day called, and the 3.6 family, the 3x family was born in a way that was in some cases not backward compatible,
right?
And that ruffled a lot of feathers. But today you can actually write code. I mean, a lot of the code that we write can be run in 2x or 3x world. So a lot of cleanup in the language. I mean, every language really goes through this, from C# to C++, to any language. You learn. There's new stuff that comes along. There's new factors that come into play, and you have to support it. So Anaconda comes with both 32 and 64-bit flavors with both 2.7 family and 3.6, 3X family, and the IDEs support all of them. At Microsoft, we strongly suggest and promote 3X. Lots of internal teams that are just coming up on providing wrappers for their services because customers are asking for them. We basically tell them, just go 3X. You can't look backwards. Yeah, I mean, that's one of the things I should mention, that on our team alone, it's a small team, but we have 3 core Python committers. So we work with Guido and the team to actually work on some of these language features. And beyond just language features, we do things like Dino and Brett just got their PEP accepted to allow Python to be JITted. So we have a framework that for the 3.6 interpreter that allows you to generate machine code using the CLR jitter. We use that as a test bed to spit out machine code, but essentially it's available for anyone to plug in their own code generator to speed up Python, which is normally interpreted and not the fastest language.
So you've gone from an interpreted language, right, where everything happens in one pass, to a 2-pass system where it JITs it first and then it runs it a little bit faster.
Yeah. You can basically, for any method, you can pass it to the code generator. It can look at the IR and spit out the code, and then from then on, whenever that method gets called, actually switches to the JITted code. Yeah, I mean, there have been other attempts at this. Google has tried it, others have tried it, and all of them have basically fizzled out. We're happy that this one got accepted into the main trunk, and we'll see what people do with it.
So you mentioned something like Anaconda, and I've seen this recently when I'm installing, because when I install Python, I usually just go to Python, I install it, I put it on the C:\Python 3.6 path, and then I just go from there. Then I make sure pips is installed, and I do everything from there. What does Anaconda do that's different from how I usually install Python? So
what you're doing is perfectly fine. You start minimally with what you need and just lazy load essentially whatever you need. Anaconda gives you like 200-300 packages that are well tested together. Version matching is a problem in just about any ecosystem. So this is from Continuum.io. Shout out to Peter and Travis and company. They've done a fantastic job of essentially erasing the OS differences by saying, look, write it in Python. Here's like 300 really popular languages, and whatever else you need, you can conda install or pip install. But the core stuff, especially for data science, which is made up of NumPy, SciPy, Pandas, scikit-learn, et cetera, all of them are instantly available. So you can have a friend in your team that works on a Mac environment, somebody on Linux, somebody on Windows, and you can easily share directories and be 99.853% sure that all of it will work the same way.
Yeah, because usually when I'm installing some code, I'm like, oh, you don't have date util or something. I'm just like, pip install, right? And usually this happens right before I have demos, friends. I have the wrong. So you're saying if I have Anaconda install, it will have everything there nicely.
Yeah. Easiest is to install Visual Studio 2017, check mark the data science workload, and you get a full, complete environment for everything you need, just about everything you need, ready to go.
So when I install it via Visual Studio, because I think I did install it via Visual Studio, and then I also installed Python on my is that going to screw things up? Should I remove what I did? And
so if it's done through the main installer for CPython, is it on Windows that you did? Okay. So our team actually produces the installer for CPython for Windows. Steve Dower, the lead on the PTVS project. So if you install it through that, it has a proper registry key and the right layout. And if you go into Visual Studio, it will detect it as one of your environments. And you can have 4 or 5, whatever environments you want. You can switch between them. 2.7, 3.6, 3.5.1, whatever you might want.
That's so what Visual Studio is doing is it's installing its own Anaconda setup. But if I have my own setup that I want to test on, I can do that as well.
Absolutely. And beyond that, you can install Jython, which is Python on the JVM. You can install PyPy. You can install IronPython, our old good old Python on.
I remember
.NET.
that.
Yeah.
That was a cool thing because back then with IronPython, I remember I had a customer that was like, "Hey, I want to write reports, but I don't know what they're going to be." I embedded a IronPython interpreter, and it just generated data for any report at any time. And they said, "Oh, I need a report," so I Pythoned it in, and it was done. Which was pretty cool.
Yeah, it's very. Yeah, I mean, lots of credit to Dino Wieland, who was one of the original devs and leads on IronPython. And essentially for the past 5-6 years that we've been working on Python, he's been one of the key contributors on essentially PTVS, on IronPython and Jupyter Notebooks. So, and he's also a core Python contributor. The project is alive on, I don't know if it's on Codeplex or GitHub these days, and it's got a vibrant community, and people are supporting it, and essentially for embedded cases like this.
And I did not know that was still happening. That's pretty cool.
Yeah, there's IronPython, there's Python.net that allows you to use CPython from .NET environments. So, yeah.
So let's talk a little bit about Jupyter Notebooks, because to me that was it was a super interesting thing. I remember the first time I saw it, like the bells and whistles kind of went off in my head, and I thought to myself, if I would have learned machine learning the way these things are laid out, it would have been much easier. I could have changed numbers, I could have seen things happen. Why don't you describe what Jupyter Notebooks are and why they're so important?
So first of all, I'm really excited that the co-inventors of Jupyter Notebook, Brian Granger and Fernando Perez, and their teams, well, actually Fernando couldn't make it, had to cancel last minute, but the rest of the team is right here.
That's awesome.
And giving a talk on Friday. You should watch it. So Jupyter Notebooks, for people that haven't seen it, it started as the IPython project, which stands for Interactive Python.
Right.
You know, Python gives you a basic REPL. The IPython environment gave you a little bit of a richer REPL experience with up arrows and completions and so on. Then once the web stuff happened and people said, look, I need to do like essentially a scientific paper, which today you do it on a PDF.
LaTeX.
Yeah, you get a PDF, it's got text, it's got graphics, it's got some code, but it's like dead and boring.
Sure.
Like, why can't I give you this thing in a live fashion where you can, if you don't trust my algorithm, you can go and change it, point it to your data, and run the code and check it, right? So Jupyter combines Markdown, executable code cells, math formula beautifully rendered, interactive widgets that you can move a slider and so on. It'll almost create a beautiful dashboard. And it's all a URL. I can hand that URL to you, and you can go fork it and play around with it, or just look at it, and so on. Like Satya was going around about a year ago, and people were showing him demos. He was spending average like 4 minutes in each office, and we had built a prototype of docsmicrosoft.com that essentially took a few of the samples, and instead of just being, is there HTML, text, code, whatever, we actually made it a Jupyter Notebook that you can run the code immediately. He stayed in our office for 23 minutes.
Which is a long time.
A long time. So he was totally getting it immediately. He said, okay, I like this, it has potential, and we should go forward. Long story short, Jupyter Notebooks as a service is available for free for anyone to use at https://notebooks.azure.com. And you have R, Python, and F# and Anaconda and everything else that you need. And you can just go ahead and party on it. We have lots of samples on the front page if you want to learn Python, if you want to learn F#, if you want to learn data science. And we had about a couple of thousand users. Yesterday I checked, it's like 32,000 users, and it's climbing like crazy. Originally, we did this as a thank you to the Jupyter and the open source community whose software we use all over the place. And we thought, like, if a lot of, maybe second, third tier universities used it because they don't have all the rich endowments. What we found out was, like, from Harvards and Browns and Stanford, all the top tier universities are uploading their courses and assignments and whatever is up there. And I was curious as to why. So I pinged a couple of them, and apparently there's like a war going on between professors and the IT departments. So as soon as this thing showed up, they just like jumped on it. So we hope that in the education market, a lot of people end up using the service.
Yeah, and like when I was studying this stuff, we got these PDFs, right, or these slide PDFs that my professor would give us, and it would have been super handy, for example, when I'm learning logistic regression, to change some of the numbers, or to see what it was like if I could see if I could plug regularization in, for example, and instead of getting this PDF where I can't do that, you could do this live with Jupyter Notebooks.
And exactly, and at the end of the day, once you do your work, you do your rappelling around. You want to present your work as a data scientist. You need to explain what this black box does, right? Or if you're a professor and you want to, describe some engineering process, you've got graphics, you got text, you got essentially what a good textbook does. But that code can be live now, which is the key point. And then I can share it with thousands of people. So if you go on GitHub, there is over 1 million public Jupyter notebooks there, and the rumor has it there is about 1 million private ones, and the Jupyter ecosystem is in the 4 to 5 million user range. So it's pretty substantial. Which
is amazing, and in fact, Miguel de Icaza was so enamored with this that he made C# notebooks.
Exactly,
as well,
Xamarin Notebooks.
Yeah, Xamarin Notebooks, that's right.
Exactly.
That's right. So we only have about probably 3 or so minutes left. Why don't we talk about what some of the stuff that we're working on at Microsoft to enable communities to use Python in our tooling? Or what are some of the things that they can look forward to?
Sure. So first and foremost, I'm delighted to say that VS Code and its Python plugin creator, Don Giamatti, is going to join us.
Oh.
And we're going to be focusing on making that plugin even better.
I love it.
By using some of the technologies that we've built for PTVS, Python Tools for Visual Studio, into VS Code. We have R for Visual Studio. We hope to do the same thing for VS Code for R, given that a lot of the R users are cross-platform. And so actually, the RTVS product has some really advanced features, like you can be inside Visual Studio and remote into a Windows server or a Linux server that's coming up. And this is not just an R login. This is everything that you can do in Visual Studio mirrored onto a machine that's sitting out in the cloud. So you could have your laptop, but you want to do your training and you need a fat box with lots of GPU power. That's the scenario that we're going to light up. And that could be Linux or Windows. You wouldn't know or you wouldn't care. Obviously you can choose either one, but R and Python being very cross-platform, that stuff is sort of fuzzed out for you. And we're spending a lot of cycles on making sure the Azure Python SDK is first rate. Lots of people don't know this, but the Azure CLI now was just rewritten from Node.js into Python. So yeah, it's cross-platform obviously, and whether it's Linux, Windows, whatever you're using, you can just pip install Azure and you get the rich Pythonic bindings for all of the Azure services. And of course the Jupyter notebooks that I talked about, we're partnering with Data Camp to have their courses, some of their courses on there.
Nice.
And O'Reilly has actually started publishing their books officially as Jupyter notebooks. So for the first one, Jake Vanderplas, a professor from UW, who's written the famous Data Science in Python book for O'Reilly, they're going to actually have that as Jupyter notebooks, and it's going to be on the front page of Jupyter service that we have, and anybody can run it and use it for free. So lots of exciting stuff.
That's amazing.
Yeah, and I haven't even gotten into the database and Azure Stack parts of it. Lots of cool stuff. perhaps the next.
Yeah, we
interview
should
can do
definitely
that.
spend some more time because, like I said, I love Python. It was what I used. It's what broke me into data science. I loved using NumPy and
Fantastic.
SciPy. It was Matplotlib. I mean, that's
Yep.
how old I am, I guess.
Yeah.
But
You should
it's,
take a look at Vega now.
is that the new one?
Yeah,
Oh,
yeah.
See, we need to spend some more time with this guy. Thanks so much for spending
Thank
some time
you.
with
It was
us.
a pleasure. Thank
Thanks-
you.
Thanks so much for watching.
Thank
We'll
you.
be back right after a tiny break. We'll see you then.